Hopefully you got a camera. Okay, awesome. Let's go. Good. I think it's still morning. So good morning, everyone. Great to be here. Thanks for organizing this fantastic workshop and amazing set of speakers. So I'm Jamie. I'm from Wayve, and I lead our research team, among many other things. And I'm going to be talking a little bit about Wayve and where we are and where we're going, and a few little sort of research snippets as well towards the end. So the open road, the thrill of acceleration under the big blue sky as you put your foot pedal to the metal and accelerate through the open landscape. Well, unfortunately for most of us, the reality of driving looks much more like this on a day-to-day basis. And in fact, the average North American driver spends, I'm told, 2 full days of their lives each year stuck in traffic. Wouldn't it be amazing if we could get that time back to read, to play with our kids, to work? More seriously, there is a huge toll we pay as a society for our use of the roads and our mobility. Statistics from the WHO here. And the sad fact is that the majority of those accidents are caused by human error due to these or other reasons. These are things that machines shouldn't fail at. And so I'm far from the first person to have asked the question, wouldn't it be great if cars could drive themselves? And for these reasons, plus the potential huge economic possibilities of this, self-driving has become the space race of our generation. And we've seen just a few of the companies in this space already this morning talking here on the stage. But despite progress, we still see almost daily headlines like this appearing in news outlets. Now, some of this is unfair, absolutely, and usual media hysteria to plug holes at things. But equally, it's very true that autonomy is not yet everywhere. We've seen great examples of Waymo. They've done an amazing job at deploying robo-taxis, but they're in a very small handful of cities around North America at the moment. We just saw Tesla, and they've done a phenomenal job with self-driving. We'll come back to that in a second. But Tesla only sells 2% of the world's automobiles. How do we get this to be truly ubiquitous? And that's what we're working on at Wayve. What does this mean? Well, it means wherever you go, any city around the world, this should just work. Whatever vehicle you're in, it should have autonomy built in. And ultimately, it's not just about cars and automotive, but it's about all of these other forms of autonomy and robotics that could transform how we work as a society. So a little history lesson. We've heard a little bit variants of this over the course of the morning, but here's my take. So after the DARPA grand challenges in the 2000s, people started to wake up to the possibility that self-driving might be a reality. And that was further accelerated by the advent of ImageNet and AlexNet and all of the excitement of CommNets in the 2012s and beyond. And that's led to some of the early investments in this space. And they took a very reasonable approach, you'd think, as an engineer. Let's throw some sensors at this. Let's throw a bunch of computer vision perception algorithms at the problem, recognize the pedestrians and the cars and other things. And let's use maps, right? We know now how to map out cities to centimeter level detail and to localize ourselves against those. And then once we've got all of that information, great. Let's then feed that into a hand design set of rules, or more lately, a learned set of rules for planning and prediction. And then that actuates the vehicle. And this can be made to work. That is patently obvious now. We have real deployments on the road of this today. But it has proven really slow and expensive to scale for all of the reasons that I've got up here and more. And so we've seen a pivot from at least some companies towards an alternative that I'll be talking about next. Now, while all of that was happening in the world of AV, in the world of AI, there were all sorts of exciting advances. Here's just a few and I've given up updating this slide because it moves too fast. But there was a huge sway of new developments over the last decade and a half that I'm calling here the foundations of modern AI. Things like, the data sets and benchmarks, self-supervised learning, foundation models, scalable compute and architectures, multimodality, and post-training techniques. And these have really, you cannot have missed the incredible progress that this has driven in the cognitive AI domain. And I and all of us at Wayve strongly believe that embodied AI is next. The idea of taking these same learnings from the space of cognitive AI and deploying them in robots of different shapes and sizes. Now, I remember sitting in a cafe just over the road here in Honolulu in 2017 at CVPR with Alex Kendall, our co-founder, and he outlined this vision for an end-to-end approach to autonomous driving, which sounded at the time incredibly contrarian. Nobody else was doing it this way. Nobody believed that this could be even made to work, let alone deployed on real roads. But if you look at a scene like this, the complexity of this is a typical driving scene in London. This is not Longtail or anything particularly difficult. This is what London is like everywhere all the time. And, Alex starting and founding the company in the UK and driving around the streets of London, it was patently obvious that you couldn't solve it in the old way. There had to be a new way. It wasn't about perception. It wasn't about seeing the object. It was about decision making under such a complex set of constraints. And so Alex and the early Wayve set out exploring end-to-end AI from day one. And this is the architecture. It's infinitely simpler than what you see in the AV 1.0 world. And for all the reasons we've also heard in earlier talks, it has all sorts of amazing advantages. Now, in doing this and moving from the cognitive AI domain to the embodied AI domain, there are a number of challenges. So data, you can't just scrape that off the internet and the text that sits in the internet and train your big end-to-end LLM. Well, the data doesn't exist. You have to find a source. And actually, autonomous driving is perhaps the easiest source in the general space of embodied AI because there are lots of cars being driven around, and most of them nowadays have lots of sensors on them already. But you still need to get it. You still got to make sure it's diverse, it's accurate, good quality data. Then you've got compute. Training compute, first off, you're dealing with large, high-dimensional video data. That is expensive to deal with. You've got the physical embodiment, which means you've got to deal with the fact that robots don't do exactly what you expect them to do. You've got to fit onto an embedded processor that sits on the vehicle. You can't just call the cloud and expect unlimited data. You've got real-time latency constraints. It's got to learn something about the spatial world. LLMs are great at language, but they don't typically know about the world of space and the relations between objects. Evaluation, we've already heard how challenging that can be. How do you evaluate these models when the real world never does the same thing twice? And of course, building trust, safety, validation, and explainability. So we've been working on this since that 2017 here in Honolulu, and we started life in London. And here's more snippets of where we've got to. So London was this amazing proving ground because it forced us to develop end-to-end technology quickly, rapidly, and get really good at it. And about this time last year, we started expanding globally, first to the US, and then more broadly, and I'll show you some more examples here. But it's been really both unexpected and humbling at the same time to see how well this has worked. Our hypothesis from day one has always been that end-to-end would allow this kind of global scaling. And now actually seeing this deployed across different cities different road types, and different countries across the world. It's been really exciting. And so on the back of that, we're now working towards production and working with various partners around the world to ship our AI driver into their stack. And it's built for any vehicle. It's designed and trained with diverse data that allows us to quickly get it onto new vehicles. It's built for any environment. We don't have to have HD maps. We don't have to pre-scan environments. And designed ultimately to scale all the way from L2 plus all the way up to L4, depending on the sensors and the compute that you have access to. So a couple of case studies. First off, when we went from the UK to the US, well, we had the small matter of going from driving on the left side of the road to driving on the right side of the road. So unsurprisingly, you start with a zero-shot test here, and it doesn't do particularly well. A big drop in performance, as you'd expect, compared to our UK benchmark. But with only a very small number of amount of additional data, we could quickly see this ramp back up to the performance we had been expecting in the UK. But more importantly, the next year we went to Germany, things got better. So we had this massive drop, zero-shot driving when we went from UK to US. When we go from UK plus US to Germany as well, that drop is now shrunk really considerably. And this is what we're seeing now time and time again. The more places we drive, the more diverse data we bring into our corpus, the better our foundation model for driving globally gets. Furthermore, we see cross-domain transfer. So data from Germany is now helping us drive better in the UK, for example. And on the back of that, we've been doing a bit of a global roadshow, and we're on target to hit 500 cities across the world by the end of this year. Here's a snippet or two from that. This is one of my favorites, just a nice little winding country road in the Italian Alps, I think this is. And this is zero shot. We didn't train it to do anything special here. This is just throw this out and let it drive. Here's another example, the so-called magic roundabout in the UK. Whoever designed this, I don't know, they deserve some kind of prize. But it is a set of roundabouts around a central roundabout. And again, and what that means is the outer roundabouts go one direction, the inner roundabout go the opposite direction to anything you've ever seen before. And yet, we're still able to generalize to this kind of weird and wonderful set of road layout. Here's another famous roundabout in Paris, the Arc de Triomphe here, and driving onto this. This is a notoriously busy, unstructured road. You'll see cars driving across the traffic at all angles. This is just the kind of environment that you really couldn't do this with a traditional system. And of course, we see the weird and wonderful of the road. Here's some animals, some horses, police on horseback here in London, a squirrel somewhere in California, which we braked for a little bit, some go-karts in Tokyo, sheep somewhere in the UK, I think. And the beauty of an end-to-end system is that, again, this is all learned. This just emerges from emergent behavior. We don't have to tell it about animals. We don't have to tell it about puddles. The data's there. As we see more and more and deploy further and further, we get more data. Here's a duck that's decided to get in the way, and we'll wait comfortably until it walks out to the other side. The busy back streets of Tokyo here, many pedestrians, and this is very normal scenes. This is I love these kind of really narrow sections where we just find our way, especially when there's a lot of construction going on as well. So the most recent place we have deployed to now is in Tokyo, and here's a little snippet of the busyness on the streets there. And in fact, we've been working very closely with Nissan and announced over the last few weeks and months our partnership with them to deliver the next generation ProPilot based on Wayve's technology. And this was, again, another really powerful demonstration of what's end-to-end allows you to do. We could get zero-shot, pretty strong driving, a lot better than those last two graphs I showed in Japan. Within 3 months, we just added an additional 2% of data to our corpus, and that allowed us to get back to performance in Japan and, in fact, improve driving elsewhere across the world. And in under 6 months, we've gone from basically zero to taking Japanese and worldwide press in Nissan vehicles, in fact, in a severe typhoon that actually cancelled the Shinkansen trains. So really exciting to see that deployment. We also were delighted to welcome Jensen to London a few weeks ago. Here he is handing us an NVIDIA Drive Thor, and excited to see our partnership continue as well. So with that background in place, I'm going to talk around three different topics. The first one, language meets driving. Now, if you go and probe an LLM to ask it about what it knows about the task of driving, it will give you pretty sensible answers. I won't read all of this out, but LLMs do encode a lot of common sense understanding about the world. And it'd be great to explore, and what we've been exploring at Wayve over the last few years, how we might use this. The first possibility, I think, is explainability. Can you get it to tell the user what it's seeing and describe what it's doing? This at least partially addresses some of the challenges of end-to-end as a black box. And so, our first foray into this was Lingo 1, a few examples here of captioning, live captioning of what was going on as the car was driving around. And we took that further and extended that to a chat interface. So you could ask it, what are you paying attention to? And not only would it describe in text what it's talking about, but it would also referentially refer to the different parts of the scene to give you a really clear understanding that it's paying attention to the right things. It sees what it knows what it's seeing. More recently, we developed Lingo 2, which is actually a driving model that has the captioning built in. So previously it was, let's take a video and just replay it and understand it. But now we could live caption the drive as we went. Now, I think that's only scratching the surface of what's possible in explainability, but I think there's also other really exciting directions that we're looking at, things like representation learning, things like how do you take human supervision labels and make, perhaps describe a scene or an intervention with a paragraph of words that could save you perhaps 1,000 videos to have to capture and do it. So major potential efficiency gains there. And of course, reasoning and thinking fast and slow. How do you reason around very complex challenges that you come across on the road? The next topic I want to touch on is spatial intelligence. And as I mentioned, this is a key aspect that foundation models need to learn for embodied AI. And delighted to share a preview of some of the work that's coming out at NeurIPS later this year, called Rigor, which is a rigor-aware 3D spatial intelligence. Now, this is trained from a feed-forward, using just a feed-forward neural network and a set of camera images to output 3D poses of the cameras over time and a reconstruction of the environment. You can think of this as an extension of the VGGT and a similar line of work, but extended with camera rigs. Here's a very high-level architecture diagram. You can check out the archive paper for more details. But essentially, the key novelty is we can encode additional rig metadata into this, and that allows us to, and then we encode the individual RGB streams separately, and then a big decoder that's able to output a point map head and various ray map heads that give us the results that we are after. And compared to some of the state of the art, the addition of this rig information really helps. And you can either use explicit rig information, this example on the right, or even without that, but just knowledge that there is a rig and that there is some consistency between these views over time allows you to infer much better results as well. Of course, you train this to be robust to different environmental conditions, and of course, also across different vehicle embodiments. And there are other applications of this, for example, taking the same approach even without the rig and applying it to at-scale internet dashcam type footage that allows you to get some interesting new potential sources of training data. The final topic I want to talk about is data and how can we expand the value of data. So Jose, I really liked his talk this morning. He talked a lot about the importance of data and the various different types of data and how easy it is for, the general effect you'll see in driving data is pretty boring data. Driving down a straight road, for example, nothing's happening. Only a small fraction of data that you can capture on the road is of interest. And even a smaller fraction of that could be considered safety critical. So how do we expand, how do we find that data and how do we expand the ability to do it? How do we find examples like this where, cars are overtaking or cutting in, dangerous things happening on the road? Well, those are actually synthetically generated based on our Gaia 2 world model, which is able to generate photorealistic, temporal and spatially consistent multi-view imagery with high controllability and geographic diversity. The architecture looks a bit like this. It's a latent diffusion model. You can read the paper for full details. But essentially, we're training this to generate videos conditioned on various things. So we can control the scene based on things like cuboids, embeddings, metadata. And it's a world model, so we can condition it also on the actions of the ego vehicle. And we train it to generate either from scratch or from some initial context, or even things like in painting. So what can it do? Well, if you just let it generate purely synthetically, you can get some really interesting, diverse generation coming out of this. Beautiful scenes represented in different times of day, different countries across the world. You can ask for specific scenarios. So here we've asked it, generate me various examples of diverse scenarios of overtaking a bus. And lo and behold, you get various different examples here, different times of day, different traffic conditions, road conditions, etc. Here's another example with U-turns. Same story. As I said, it's a world model. It's action conditions, so we can actually steer the ego vehicle into the oncoming traffic and aim to cause a collision. Well, actually, the other vehicle here responds and moves out of the way, but still a really interesting new piece of data. And this is something that wouldn't, of course, exist in our default training corpus. We can start to generate emergency vehicles by slowing down the vehicles ahead of us. Or even more severely, take a pretty mundane bus driving scenario on the left there and turn this into an actual crash scenario. Look. Here's another variant of scene editing where we take a fairly normal overtake a bus scenario and replace that with a version where the ego vehicle rapidly speeds up into the oncoming traffic. And perhaps the most interesting of all, I think, is this fairly normal scene in Tokyo, where instead we steer the vehicle across the median and into the oncoming traffic. So this kind of technique opens up enormous possibilities for generating synthetic training data and also for generating synthetic evaluations. Beyond that, we can do some interesting things. So again, if you've got a big corpus of dashcam data, for example, you can now start to turn that into multicam data. Again, fully temporally and spatially consistent. If you have, say, a LiDAR scan of the scene, you can take that LiDAR and turn that into surround RGB data. And I think probably my favorite of all is this one, where we deliberately steer the vehicle off the road, starts fairly normal, across the traffic, off the road, into the forest, through the trees. And, you know, this one to me is kind of magical because this is not something we've got in our training data. I don't know quite how it's able to do this, but this is just the sort of magic of machine learning and large-scale generative models. So I've mentioned many ways that this could be used. I think perhaps the most exciting and one we're continuing to look at is learning in simulation. So, you know, all the way from 2018, the World Models paper from Harald Schmidt-Huber showed this for game playing. Actually, Wayve did some very early work in this space, Dreaming to Drive. And this is a policy that was learned purely in simulation, only taken in, you know, it wasn't taken on public roads, but very interesting at the time that it was able to learn model-based RL in that space. And of course, we see more modern examples of this as well coming out today. I think this is going to be a really fascinating area of the development for embodied AI. So I'm going to wrap up. Wayve is paving the way for safe, scalable, auto-grade AI that can bring autonomy ubiquitously across the world. But stepping back and zooming out, embodied AI promises to transform human interactions with technology. I think this is going to be a really incredible time, the next 5-10 years, as embodied AI starts to leave the lab and really enter everyday life for most of us around the world. But for this to really work, we've got to do it right. And here's a few pointers that I think are really important. It's got to slot into our messy world. We're not going to change the world just for our robots. The robots have to coexist with us, with both the cars and their human drivers, but also bicycles, pedestrians, etc. We've got to have an economically viable approach to this. It's no good having something that is so expensive that even though it's, you know, so much safer, it can't reach widespread deployment. It's got to be economically viable and also improve safety. It's got to be accepted by the public and regulators, meet our expectations of safety and reliability and explainability. And of course, it's got to add value and utility to our lives. So with that, I'm going to wrap up. I'm going to give a big shout out and thank you to the amazing team we've built at Wayve. It's been humbling to see the sort of exponential growth of the company over the last few years. You know, the incredible work that the team does. Now, we're hiring. We've got amazing opportunities across the world. If any of these topics sound of interest to you, there's a QR code there where you can drop us an email at ICCV2025@wayve.ai. We'd be delighted, and I'd also be delighted to talk to you after the talk. So with that, thank you very much.
All the question, yeah, I mean, we can distribute the